Welcome back, everyone. In this episode, I want to talk about a sorting algorithm called merge sort. I will teach you how merge sort works, understand its time and space complexity, and even provide you with the C++ implementation. So let's say we have a list that needs to be sorted in ascending order. First, we call the merge sort function on the list, which divides it into two halves. We will then recursively call the function until each sublist contains only one element. Next, with the help of a second function, we can call it merge, we will sort the individual sublists and merge them back into the final list. So this function will have three parameters: the left sublist, the right sublist, and also a reference to the original sublist in which the elements came from. The merge function will take these elements and put them back into the original list, but this time in ascending order. We will continue doing this until we have reached our complete list, with it being sorted now. So as you can see in the first example, where the merge function will be called, there is no changes. It simply merges them back to the list. And then this is the second layer. So as you can see, this branch and this branch is now merged together, with it being sorted now. And lastly, we merge this branch together with this branch and we get our sorted list. So the merge sort is a divide and conquer algorithm because we split every single element into its own array and then we merge them back together. And that is basically an illustration on how a merge sort would work. The time complexity of merge sort is O n log n, together with quicksort and heap sort, which we still need to talk about, so make sure to subscribe to never miss out a future tutorial on it. And merge sort is also faster than algorithms like insertion sort, selection sort, and bubble sort. However, when looking at space complexity, merge sort uses O of n, since we need to create sublists in memory for every element in the list, which makes it less efficient at utilizing space, such as insertion sort, which uses space complexity of O1. So again, depending on which program you have to build, using merge sort can be either a disadvantage or an advantage, because merge sort is faster, but it takes up more space in memory. And that is all I had to show in about how merge sort actually works. Let's actually take a look at the code on it works. Now the code is written in C++, but I'm sure you will have absolutely no issues in implementing the merge sort algorithm in your own language, whichever one you're using. So let's get started. So we have a list that needs to be sorted and we will use the merge sort algorithm. So let's actually run the program to actually show you that it works. And as you can see, we have unsorted and then sorted here. This for loop gets run after we call merge sort on it. So let's talk about the merge sort function. We check the base case where the length of the input list is less than or equal to 1. If the base case is met, we return from the function. We calculate the middle index of the list and create two new vectors, left array and right array, to store the divided subarrays. Using a for loop, we iterate through the input list and assign elements to either the left array or right array based on their positions. We then recursively call the merge sort function on the left array and the right array vectors. Finally, we call the merge function, passing the left array, right array, and the original list vector as a reference. This function will then merge the sorted subarrays back into the original list. So let's actually talk about how the merge function works. Like I mentioned previously, the merge function will take in two sorted subarrays, the left array and right array, and also a reference to the original list. We initialize the variables left size and right size to determine the sizes of the left and right subarrays. Left size is calculated as half the size of the original array, while the right size is then the remaining size. Using a while loop, we compare elements from the left array and the right array and merge them into the array. The loop continues as long as both L and R are within their respective subarray sizes. Inside the loop, we check if the element at left array L is smaller than the element at right array R. If so, we assign left array L to array I, increment both L and I, and move to the next element in the left array. If the element at right array R is smaller or equal, we assign it to array I and then increment both R and I and move to the next element in the right array. After the while loop, we handle any remaining elements in either the left array or right array and place them in the array. And once the merging process is complete, the array now contains the sorted combination of the left array and the right. And that is basically how you implement the merge sort algorithm in code. And that wraps up our exploration of merge sort. It is a powerful algorithm that utilizes the divide and conquer technique to sort data efficiently. Merge sort achieves a sorted list by dividing the problem into smaller subproblems and then merging the results. Thank you for joining me today, and hopefully you've learned something new. And make sure to, subscribe, like, and also check out my other tutorials while you're here. Stay tuned and goodbye.